Hi. Now about the ray diagrams. This I mentioned it along with my lesson where I have described mirror images, etc. But then just to, as I said, a recap. If you're asked to find the position of an image in a plane mirror, uh, again without using a protractor, you can construct the diagram accurately. How do we do that? Now, say if there is a plane mirror and that's your non-reflecting surface. So if you have say a tree in front or any irregular object, you are expected to construct a ray diagram to find the position of the image. Now all of us know where exactly the image will be by theory or by real life application. It will be formed at the same distance from the mirror and so on. So what would actually they be expecting? Your rays, how are they passing through? Are they passing accurately or they reflecting accurately will be tested. So what you do first is measure one of the point, say this distance you measure it to be say 7 centimeters, measure the same distance here and that's your point, correct? Now this point you have to achieve by completing 2 light rays minimum, alright, that is incident on the plane mirror. Now what's the rule? The law of reflection says the angle of incidence equal to angle of reflection and so on. Yes, you may construct your drawing normal, you're measuring the angle, etc., all those procedures. You have to extend so that all these rays will meet at the same point. That's a principle, right? From the same point, how many ever rays are incident, they are reflected, they will appear to come from the same point from behind the mirror at the same distance. Now for construction of this, you just need 2 light rays only. So what I'm going to do is I'm going to reverse the process, which is I know that if I connect the reflected ray, it should meet at this point. So you place a ruler so that this point and here that is connected. So that will be your imaginary line. You connect it to dotted and then extend this line back. So that's your reflected ray for the first one. The second one also you follow the same procedure. You join these 2 dots. Sorry. And then extend it. Okay. I've constructed the ray diagram. In less than a minute, you can complete this ray diagram if you follow this method. But then if you don't trust me, what you could do, or to give an indication to the examiner, you have measured the angles, and addition to this, in the middle you just draw the normal and measure these 2 angles and check. Alright, it will be equal. Okay. Now this also you can draw a normal and measure these 2 angles will be equal. Now why have I taught you this method? As I said, to save time, because if you make an error of even 0.5 degrees in the measurement here, if you're following the conventional method, then what will happen? These 2 light rays will not meet at this point. It'll be above or below. Those of you who have practiced would already, who already practiced might have come across this situation. You're erasing it and again constructing it. So you'll be wasting more than 5 minutes there. Okay, using this method, you can just construct it accurately. That's an important point. Accurately in less than a minute, if such questions come. Okay, that is one. Then I also wanted to stress on the lens when you're constructing ray diagram for, say, a convex lens. We usually draw 2 light rays and leave it there. So if you have the object here, so you just bring it to the middle of the lens and then it has to pass through F. The second ray has to pass through the center of optic center. It goes straight, so there is no confusion. Now, is there any other ray that you could construct? Yes, there is one more ray which usually we forget. Now if you drop this line, so this is a parallel line from here, where should this pass through? This should pass through F on the other side. Okay, I have not drawn it accurately. Hence, if you connect this should be your F on the other side. This again you can try it out, construct it using actual ruler and all. So these 3 light rays you can keep it in mind. Sometimes they ask you to find what is the focal length or focal point of the particular lens. So there are some lines already drawn to you. So it's clear, or by theory, you should know these light rays pass through one, through F will go parallel to the other side. The parallel light ray will go through F. Parallel light ray will go through F, and if it passes through F, it will go parallel in a convex lens. Keep these points in mind, and I'm sure uh, ray diagrams or diagrams you will get it right, and you will not waste too much of time on that. All right. All the best for your exams. See you. Bye.